Assalamu alaikum kids. So today's topic is standard form. This right here is one of the prerequisite topics in physics, and it's very important that you understand how to write numbers in standard form to do well in exams. So what is standard form? Now standard form is essentially a method used by scientists to represent very large or very small quantities. Example, the mass of sun, which is a very large quantity, or the mass of an electron, which is a very small quantity. All right. Imagine yourselves writing these quantities again and again during calculations. It's going to be a big problem, right? So scientists have essentially created this method standard form, which makes it easier to write it. We're going to go through some of its rules. Rule number one: only one non-zero digit is allowed to the left of the decimal point. So example here, 7 is the only digit to the left, so it's fine. 49.7 has two digits to the left, so hence it's wrong. Rule number two: 0 is not allowed as the units digit. So 0.123 into 10 raised power minus 3. Again, 0 is the units digit, so not allowed. On the other hand, the same value can be represented as 1.23 times 10 raised power minus 4. Here, 1 is the units digit. So that's completely all right. Now, how did the 10 raised power minus 3 become 10 raised power minus 4? We're just going to take a look at it later in this slide only. So rule number three: if the decimal is moved to the left, powers are added. Cool. So decimals move to the left. So in this case, I'm going to have to move this decimal point right here to the left to make it into standard form. Currently, how many decimal places are to the left? There's there's 4 digits to the left of the decimal place. I need only one. So I'm going to have to move the decimal place 1, 2, and then 3 right here. So this right here becomes 2.34545 into 10 raised power 3, and hence it's converted into standard form. If decimal places move to the right, the powers are subtracted. Example 0.003456. Now in this case, there's 0 to the right left of the decimal point. So I'm going to have to move the decimal place to the right such that, or to the point where I have a non-zero digit to the left. So I have to move it 4 digits to the right. Alright, so now you have 3.456 into 10 raised power minus 4. Now you just need to remember, why did we add the 10 raised power 3 and why did we add the 10 raised power minus 4? We're going to talk about that in the next slide. For now, what you need to remember is that only one non-zero digit is allowed to the left. 0 cannot be that units digit. If the decimal place is moved to the left, powers will be added to the 10, and if decimal is moved to the right, powers will be subtracted from the 10. Now the fourth rule can be seen in work in rule number 2 as well. 0.123 into 10 raised power minus 3. If you move the decimal place 1 place to the right, you subtract 1 from the power. So if minus 3 minus 1 now becomes minus 4. So we can see the rules in the working as well. All right. Example 1. You have this very large number 795 and then 7 zeros ahead of it, and you want to convert this to standard form. Very simple. First thing that we are going to do is we're going to choose the first non-zero digit, all right, which is 7. Then you add a decimal place after the first non-zero digit. So you write the complete number itself, but you add a decimal place after the first non-zero digit. So it was 795 and then 7 zeros. We are going to add a decimal point right after the 7. Then we count the number of decimal points 1, 2, 3, 4, 5, 6, 7, 8, 9 after the first non-zero digit, and that number of decimal points or that number of decimal places is going to become the power of 10. So the final form of 795 and then 7 zeros is actually going to become 7.95 into 10 raised power 9. To convert a very small number into standard form, the method is fairly simple, straightforward, and similar to converting a very large number into standard form. First, you have a very small number in front of you on the screen. Again, you choose the first non-zero digit, which is 1. You add a decimal place right after this digit. All right. So however many zeros 1 to 5 now becomes 1.25. Having done that, you are now going to count the number of digits before the first non-zero digit in the original number. We kept the 125.1.25 we've done. All right, so we've done some of the work. Now, before the first non-zero digit, we need to count the number of zeros. There are 1, 2, 3, 4, 5, 6, and 8 zeros before the 1 in this number. You can pause the video and count for yourselves. Having counted the zeros, what are we going to do now? We are going to add 1 to the number of zeros we just counted before the first non-zero digit, and we are going to add that as a power of our number. So in this case, it's going to become 1.25 and then 10 raised power 9. But this time around, the power is not going to be positive. It's going to be a negative number. Why? Because we are converting a very small number into a very large number. And as we discussed in rule number 4 earlier, that if you're moving the decimal place to the right, you're going to subtract powers of 10. So in this case, because we are moving to the right, the powers are going to be negative rather than positive. So the final answer is going to be 1.25 times 10 raised power minus 9. So what if we have a number that is expressed as powers of 10 but is still not in the standard form? All right, so example, we have 452.7 times 10 raised power 4. This is not in standard form. We want to convert this into standard form. How do we know it's not in the standard form? The idea is very simple. You've got 1, 2, and 3 digits to the left of the decimal point. So again, what was the rule? Rule number 1, only 1 digit to the left of the decimal place. So we want to convert this to standard form. We can do that by moving the decimal place two digits to the left. So moving the decimal place 1 and then 2 right here. So you move the decimal place 2 digits to the left, and according to rule number 3, we saw that if a decimal place is moved to the left, powers are added. Now we already have a power 4 here. We are just going to, because you added because you moved 2 decimal places to the left, you are now going to add 2 to the power of 10. So the final answer is going to be 4.527 times 10 raised power 6. So we can see again, just to recap, you moved decimal place 2 places to the left, and you essentially added 2 to the power. So it now becomes 4.52 times 10 raised power 6. To change the powers of 10 in the standard form, again, moving to the left resulted in powers being added. This time around, let's say for example, if you have this number right here, 0.000345 into 10 raised power minus 5. Now we know that this is not in the standard form. Why? Because 0 cannot be a unit digit in standard form. So at this point, I can see that we'll need to move the decimal place to the right. So what's going to be the correct one? 0.000345 will be written as 3.45. So you move 4 decimal places to the left. This right here is going to be the new position of the decimal point. And then you have your number in standard form. Again, you need to add multiplied by powers of 10. So we've moved 4 decimal places to the right. Now going back to rule number 4, you move decimal places to the right, powers are subtracted from 10. So this time around, you move 4 decimal places to the right. 1, 2, 3, 4. You move 4 decimal places to the right. You're going to subtract 4 from the power. So this right here is going to become 3.45 times 10 raised power minus 9. Alright kids, so that's it for this video. Inshallah, I'll see you in the next one. Bars out.